Hello, I'm going to be demonstrating a draft for a solution to produce self-improving agents, but just a caveat, we are not at its current state and within the scope of the draft, it is only addressing how to produce a self-improving LLM call. This is because this solution does not address calling tools. It does not address dynamic workflows, which are the two tenets of an LLM agent. It is only addressing producing the best output for an LLM call. So to begin, we have a key. This key consists. Sorry, I first gonna introduce the key. So the key is gonna have a target, which, as you can see here, is basically the LLM call that we want to update and improve. The reason I have this is because there might be several LLM calls. There's going to be several LLM calls in this draft. Then we have the color gray black, which indicates that this is something that might be introduced in a future version. Then yellow indicates an action, blue indicates an observation. The reason why I have these two keys is because um, the way the system is being built is guided by reinforcement learning, where actions and observations key um, are a key concept in order to build a reinforcement learning system. So I basically projected those two concepts over to my solution. So first, before we even get into the solution, let's just cover um, what is the common workflow for a developer that wants to create an LLM and who wants to create and optimize an LLM call. So first, the developer is going to configure the LLM call, which may consist of a system prompt, the chat history, an output constraint, which is comprised of two aspects. One is the structure, which is more often than not which more often than not is set and then persisted, and then the details, which are set and might be iterated on. Then you have the metadata, which consists of temperature and top K, top P, which modify the way the LLM samples things. Then you have the model itself, and then the eval prompt and eval rails. I will address the eval in a moment. So once you have these parameters set by the developer, you pass them over to the LLM to make the LLM call. Um, and the LLM call is made. And if you pass in an instrumenter, which is something that basically wraps the LLM call, it is able to observe the parameters and the outputs of the function, which in most cases is going to be like an OpenAI um, schema SDK that calls some provider. So once you attach that instrumenter, the instrumenter then keeps track of the inputs and outputs, and then once we have those inputs and outputs, the inputs being what we already addressed over here, and then the outputs being what is generated by the provider, you pass those two over to the eval. So now let's address the eval. The you have you may For all intents and purposes, we are going to be addressing the eval as an LLM as a judge. And what an LLM of a judge as a judge consists of is basically you pass in a prompt for the LLM judge to judge your inputs and outputs. So in the case that you want to just improve formatting, then you're going to have the inputs that you've already provided, and then it's going to have an output that may or may not be formatted correctly. And then in the eval prompt, you're going to tell it, hey, this is the format that I want. Um, once that once that prompt is provided, then um, you also pass in the rails, which are just to constrain the output space to either some scalar, some discrete number, or some category. So in our case, we would say like either formatted or not formatted. Um, and so we pass all of this information into the eval, and it's going to determine whether or not the outputs are formatted or not formatted. And that's where that will produce a score. In addition, Arise, which is going to be our telemetry system that provided the instrumentation, also provides an explanation to why the score is what it is. And so we can also tap into that, but this would be option. This is the explanation is optional. So once you have the exclamation score inputs outputs, you pass that all to be stored inside Arise or the Phoenix uh, telemetry platform, the telemetry platform of your choice. But in my case, I'm basing this off of the Arise platform. So moving forward, so what is the actual solution? And before I forget, so once you have that information, what a developer does is they look at the logs from Arise and Phoenix, look at the inputs and outputs, but oftentimes that we were talking about um, hundreds of input output pairs. You don't have time to really look at it, so instead you'll just look at the scores and get a gist of like how things are actually performing without having to look into the nitty-gritty details of things. So the developer observes this as needed and then makes a decision as to what needs to be changed. So what can actually be changed? I haven't addressed the colors here. Well, the developer is more like the developer is going to most likely change the system prompt, details, metadata, and model. These are the actions that the developer can take. The rest are just observations. Like the chat history is not in the developer's control. That is up to that's up to the user, or at least whatever information is being passed to the developer. The structure, that is also dictated by whatever contract the developer needs to adhere to. And then the eval prompt and eval rails, ideally you don't want to change those. Otherwise, you're kind of cheating your own evals. Um, yeah. So these are the yellow industry indicates what the developer can actually change. So moving forward, you have we're gonna move. Oh, and once those are changed, you iterate again. Same process over and over and over. The developer iterates until they have like an optimal LLM call. Then you have the autonomous flow. This autonomous flow, this autonomous. So this is my solution for the autonomous flow. You have the configuration that you need to set up to set this up consists of a very simple instrumenter for the eval. The only reason that you need to add this is because I'm gonna need access to the eval prompt for further evaluation during the update step. So once you have that eval instrumenter, then you're set up. Um, and what happens afterwards is you basically have the user or whatever through whatever means you end up populating and getting results, getting these input output pairs and getting evaluations. That's what you want in order to update things so that they improve. So that that's going to happen here. Here I illustrated as a user using your platform, which invokes the call provider, the target call provider, which is right here. Calls LLM provider, calls the LLM provider, and that produces a generation, and then over and over and over for however many times uh, your inference is being called. Afterwards, afterwards you have the actual update step. So what the update step consists of is, sorry, I had to switch rooms, get a bit of silence. So what needs to happen in the update step? The developer needs to configure only the date time. This indicates like from what time and onward you want to get your samples from. Once that is indicated, you're gonna move on to the data that you want to download from the data that you want to download slash query from Arise and Phoenix or whatever your telemetry provider is. So once you have that data, then you start pre-processing it. So you start to narrow it down to only the data that you need, which in our cases is going to consist of the chat history, eval score, eval exclamation, eval template, output generation, and output generation and the date time, which is what we originally filtered by. Um, Once you have all of that, you basically pass it up and into the update template. So you're gonna pass in your chat history, output eval scores, eval reasoning. You're gonna pass in as many instances of those as you need, uh, th- depending on the date time that you configured. Then you pass in the actions, and we only need one instance of this because we're assuming that you haven't changed those throughout the course of this iteration. So you're gonna have a system prompt, and then you're gonna have output constraint details, hyperparameters, whatever else. Um, you only need one instance of those, and then you have the eval template, which is provided by the eval calling instrumenter that we configured before. Um, so once you have that eval template, uh, once you have once you have each of these documents, you basically are going to pass them into an eval template that will be structured such that it basically serves as the reward function for updating things. So what would this eval template look like? It would basically consist of listing out each one of the chat history, output, eval scores, and eval reasoning, then saying, hey, here are the things that you can change in the form of a system prompt, output constraints details, and then at the end, and these were all evaluated by this eval template. And then once, and these are all evaluated by the eval template. Please update the actions so that we get better results. And so you pass that all in to the eval template. You pass that template over to make an LLM call, ideally with a very strong model, which will then make updates to the actions. So that may either be the system prompt, and may this system prompt and output constraints, and so on and so forth. And then you pass these new updated actions over to the same calls provider that you're looking to update, while also passing in the chat history and output into the calls provider, so that you're running it against the same samples that you're looking to update against, which is going to produce a series of outputs. Then you pass in all that information. You pass in all that information into the eval as before, and then the eval is going to, with the eval prompt and the eval scoring system remaining static, um, only the actions change, with the inputs, meaning the chat history, the newly generated outputs, and the same old eval. You're gonna evaluate and then see if the eval score improved compared to what you had before. And if it does not improve, then you go back and then you update the actions, and then the eval scores and eval reasoning, and it'll continue iterating until until the evaluation ends up improving. Um, once so yeah, and once your eval actually does get better, then it provides feedback back to the developer, telling him, hey, I changed this, which resulted in these better results, and apply them as you will. We can in fact even close that portion of the loop. But for this first initial draft version, that is it. I'd love to hear your feedback. I'd love to know what you think, and respond to any comments or questions you may have. It all helps in trying to build this as robustly and as effective as possible. And before I close out, what is uh, the vision going forward? So we have this system. It is grounded on reinforcement learning concepts. We can extrapolate this such that we can also take into account other LLM calls downstream in your whatever flow you're incorporating, and we can assign values, and we can assign reward values, we can assign value functions, we can iterate over time steps, so that this is scalable over to an actual agentic system, which involves several LLM calls. But yeah, that's further in the future, but this is the general idea of self-improving LLM calls. Thank you.